Find the value of sine 765 degrees. Pause the video, try this on your own. Okay, so we have talked a lot about the unit circle. In this video, we'll learn how to use it to solve these problems. Here's a step-by-step approach. The first step is to figure out where this angle lies. Forget about the sine, cos or tan. Once we know where that angle is, we can figure out the coordinates and then use those coordinates to figure out all the ratios. So 765, that's our first job, figuring out where does this lie on the unit circle. The next step is to figure out what does the triangle look like. Triangle will give us the coordinates, and finally step 3 is using those coordinates to find the ratios. So let's do that. 765, let's find the nearest multiple of pi or 2 pi. Well, 2 pi is 360, double of that is 720. So let's break this down. 765 is equal to 720 plus what's left? 45. So this means 720 is 4 pi. This means 765 is 4 pi plus pi by 4. So now let's plot this on the circle. We have this unit circle, pi, 2 pi, 3 pi, 4 pi, and then another pi by 4. So this is where we are. This is the point 765. But this is also the point pi by 4, which means the ratios actually match. Both 765 degrees and pi by 4 will give us the same ratios. All right, this is pi by 4. What does the triangle look like? What are these ratios? So this is 1, this is 1 by root 2, this is 1 by root 2. The ratios are 1 by root 2, 1 by root 2. These are your cos and sine for pi by 4. All right, we need to find sine. So sine 765 is sine of this. That's actually equal to sine of pi by 4 because they overlap. That's equal to 1 by root 2. So sine 765 degrees is equal to sine pi by 4 is equal to 1 by root 2. Let's solve one more. Find the value of tan 19 pi by 3. Pause the video, try this on your own. Okay, let's break this down, finding the nearest multiples of pi or 2 pi. So these are your steps: circle, then triangle, then ratios. To get to 19 by 3, how many multiples of pi we need? We need 6 and then pi by 3. So this is 6 pi plus pi by 3. Let's plot this on the circle. This is our unit circle. 2 pi, 4 pi, 6 pi, and then pi by 3. We're back in the first quadrant. This is your pi by 3, but this is also your 19 pi by 3. So whatever works for pi by 3 will also work for 19 pi by 3. We can jump to the ratios for pi by 3. The coordinates are half and root 3 by 2. So these are the coordinates for 19 pi by 3 as well. So tan 19 pi by 3 is the same as tan 6 pi plus pi by 3 is the same as tan pi by 3, which is the same as root 3. Tan pi by 3 is root 3 by 1. That's root 3. All right, let's solve one last problem. Find the value of tan 17 pi by 6. Pause the video, try this on your own. Okay, so let's do that. We can break 17 pi by 6 down like this. That's equal to, we can take 18 pi. That's 18 pi by 6 minus pi by 6. So that's 3 pi minus pi by 6. But there's one more way to break. We can also do this. 17 pi by 6 is equal to 15 pi by 6 plus 2 pi by 6. 15 plus 2 is also 17. This gives us 15 by 6 is 5 pi by 2. It's not a multiple of pi, but it's a multiple of pi by 2. Both of them work. This one is more convenient, but we'll try this one as well. 5 pi by 2 plus 2 pi by 6 is pi by 3. Okay, so we'll try this one first. 3 pi minus pi by 6. Let's plot this on the unit circle. 3 pi is this minus pi by 6. So we'll go back. So this is 17 pi by 6. This is the triangle. This is a mirror image of this original triangle, which has pi by 6. The coordinates for this point are root 3 by 2 and 1 by 2, which means the coordinates for this point are minus root 3 by 2, 1 by 2. We move in this direction, so x coordinate becomes negative. All right, so we have x and y coordinates for 17 pi by 6. Now we need tan, so we'll take the ratio. So tan 17 pi by 6, that's equal to half by minus root 3 by 2, that's minus 1 by root 3. All right, so that's tan 17 pi by 6. Let's try this method as well. We have 5 pi by 2 plus pi by 3. Where is 5 pi by 2? So this is pi by 2, twice of it, thrice, 4 times, and then 5 times pi by 2. We're back here. Plus pi by 3, which means plus 60. So we'll have this one We're back at the same point, which makes sense. So this is 5 pi by 2 plus pi by 3. This angle is pi by 3. The original pi by 3 is this, and the coordinates are half comma root 3 by 2. Can we use the coordinates of this point to figure out the coordinates of this one? Let's see. Let's move through the triangles. This point is half comma root 3 by 2, which means to move from this point to this point, we can take this length. This one is half, so this one becomes half. This one is root 3 by 2, so this one becomes minus root 3 by 2 because we're moving in this direction. So the coordinates are minus root 3 by 2 comma half, which is exactly what we had before. So we can match the coordinates, and if the coordinates match, the ratios will also match. We can say that tan 17 pi by 6 is equal to minus 1 by root 3. Now this is one way, a visual way of solving this problem. We can also use a lot of formulae that are there in the textbooks. By the way, these formulas are also derived visually through unit circles. So let's look at these four. These two relate pi minus theta and theta, and these two relate pi by 2 plus theta and theta. To get tan pi minus theta, we'll take sine by cos. Tan pi minus theta will be sine by cos, which is sine theta by minus cos theta. That's minus tan theta. And to get tan pi by 2 plus theta, we can have sine by cos, which is cos theta by minus sine theta. This is minus cot theta. So using the relationships between sine and cos, we figure out the relationships between tan. We can use these and we'll get the same results. So tan 3 pi minus pi by 6 is same as tan pi minus pi by 6, which is minus tan pi by 6. And tan pi by 2 plus pi by 3 is same as minus cot pi by 3. And both these values will be minus 1 by root 3. So the answer remains the same. You can try this method or the one with formulae. The objective is not to just get the right answer, but to get to the answer in the most beautiful way possible.